Yes, welcome to our presentation about Bazel beyond code, scalable data pipelines for autonomous systems. Firstly, before we dive into the technical details, let's look why do we use ROS, Robot Operating System. ROS is a robot operating system for robotics, and it's standardized and open source. So there are a lot of tools and framework that can be used and reused. It's modular, so you can plug in your own algorithms without rewriting everything. And it's widely adopted across industry and academia. And the best of it, it's already partly integrated into Bazel with ROS rules and ROS2 rules. ROS also handles how the data is shared. So the tool for that is called a ROSbag file. And think of a ROSbag file more like a flight recorder for robots. So it stores all the sensor data and the state of the robot in the file. So it can be camera data, radar, LiDAR, GNS, IMU. And to come to the next problem, that we have large amount of data robots produce, so they record a lot of data, and what you will see here is a camera stream of a robot facing in 4 different directions. And this is just one robot at one moment at a time. If you scale this up, this data gets quite enormous. So in short, collecting this data is easy, but turning that into an AI that learns fast is quite challenging. Now we have seen how much data these robots produce. Let's look into the challenges that come with that. So we have this massive amount of unstructured data, and which is hard to index or query. Usually the teams use fragmented workflow to extract that data, so the extraction step is fragmented, the selection step, and also the training, and worstly they use different tools for that. Also it has a poor reproducibility. So sometimes running the same training twice will cause different results, and that makes debugging quite hard. Further, this results in limited adaptability, which reduce model reuse and delay deployment of incremental updates. So we need a system that scales easily, ensures reproducibility, and unifies the whole process. And we think Bazel is perfect for this. So yeah, we developed a concept to unify it and then put it in 3 steps. So in the first step, the training and architecture is defined. We can use the existing tools that Bazel already have. In the second step, the data is prepared. So the amount of unstructured ROSbags gets processed into a structured training data set, and with that you can also generate metrics. And in the third step, the training is executed, so the weights get updated. And we do this because we think that for training in an AI efficiently, you also have to take the data as a dependency. So that's the core idea here. And also an important feature is the incremental processing. So when you have 2 scenarios there where the system failed, you can add that to the data. Bazel will process this data and reruns the training and initiates the fine-tuning to it. For the data processing, we developed a tool which is called Bagzel. It's a connection between ROSbag and Bazel. And this makes ROSbag data or the ROSbag artifacts executable Bazel targets. So you simply just run Bazel build, ROSbag subdirectory 1, and the specific target. So there it can be trajectories or sequences for visual data sets, or you extract metadata like map data or annotations. And it's also open source. You can find the link in the corner. In practice, what are its strengths and limitations? So its strengths, it's definitely reproducible, it's hermetic, it's composable, so you can add in your own Bazel processing rules and extract more data. It scales really well because of Bazel's hashing and incremental processing. On the other side, the limitations are there are no standardized data set format for the extracted data. Right now it only works with ROS1. There's a little hashing overhead which slows the performance on very large bags, and large files caching still remains open to solve. So in the second version we're working on large file hashing, dataset standardization, and ROS2 support. What did we change in the second version? In Bagzel v2, we adapted the hashing, and we found in the source code of Bazel and flag for custom attributes, and we used that. So what is happening is, or why do we use it? Because ROSbags can get quite huge, so they can exceed 100 gigabytes easily. And the full file hashing works good for code, but for data it's quite challenging. And how it's realized, you have a watchdog server which on the file server, which notices file changes, and it computes a hash based on file size modification date and adds that as an extended attribute. This is sufficient for AI training. And if this does not work, Bazel will just jump back to the full file hash. What do we also improve? We used external repositories. We linked our data with new local repositories into the Bazel project, so Bazel will handle the symlinks, so we need no external symlinks out of the project folder. We also adapted the processing pipeline so it works with ROS1 and ROS2, and added steps such as auto-labeling and post-processing. We improved also the data checks and were able to extract the data in a standardized format, like the new scenes format. And in the last step, we had to scale the trainings process itself. And with that, we combined Slurm, a workload manager, with Bazel. And how it simply works is that Bazel takes in the source code as a dependency, the data, and other dependencies, and checks in the Bazel cache if model weights exist. It will just fetches the weights, and if it not exists, it will schedule a training and send it to Slurm, and Slurm will handle the trainings process, and new weights are created. So this enables a CI/CD integration. Yes, thank you for listening. Thank you also to my co-authors, Lukas Bier, George Sebastian, and Mirko Melisch, who contributed information to that presentation. And I would love to exchange ideas and hear your feedback. And we can talk after the talk or connect with me on LinkedIn. Thank you.
Thank you.